Welcome to the first chapter of our course, OWASP Top 10 Minutes Hack. In this module, we're kicking off our journey through the most critical security vulnerabilities that plague modern web applications, starting with broken access control. This is where it all begins. Throughout this course, we'll walk you through multiple OWASP Top 10 vulnerabilities, breaking each one down with hands-on examples, real attack scenarios, and practical remediations. You'll see how even small oversights in code and architecture can lead to serious consequences, and more importantly, how to fix them. Broken access control is one of the most widespread and dangerous issues developers face today. If access rules aren't properly enforced, users can perform actions or access data they were never meant to, and attackers love to exploit that. So buckle up. We're just getting started. Let's kick things off. Here's how we'll break things down in this module. We'll begin with a brief introduction to clarify what broken access control actually means, why it's such a high-risk vulnerability, and how it shows up in modern web applications. Then, we'll move into a practical attack scenario. You'll see how an attacker can exploit weak access rules to gain unauthorized access to data or functionality that should be off-limits. Next, we'll dive into the code. We'll look at insecure implementations and then show you how to fix them step by step, highlighting the exact changes that turn vulnerable code into secure code. And finally, we'll wrap up with remediation strategies and best practices. You'll learn how to design and enforce strong access control mechanisms so these vulnerabilities never make it into production. By the end of this module, you'll know how to spot broken access control, how it gets abused, and how to lock it down in your own applications. Let's move to our introduction. So, what exactly is access control? At its core, it's the system that defines who can do what in an application. But here's the big question. What if that control breaks down? Can a regular user just become an admin? Sounds wild. But let's see how that happens in the real world. All right, let's start with some definitions. Broken access control refers to flaws in the rules that enforce what users can do in an app. When these controls fail, attackers can access data or functions they shouldn't. OWASP lists this as a critical risk because it often leads to major data breaches and privilege abuse. Remember that access control should always be enforced server-side. Now, let's back this up with some numbers. According to OWASP, over 318 million servers have been found vulnerable to broken access control in just the past few years. This is not theoretical, this is happening. Let's move forward and break this down with a practical example. Broken access control usually comes in two flavors. Horizontal access control, when a user can access data that belongs to another user. And vertical access control, when a user escalates privileges. For example, going from a regular user to an admin. All right, let's see it in action. User John logs into his account. He sees his balance, address, personal info, nothing unusual. But here's the catch. The app has a horizontal access control flaw. An attacker tweaks the user parameter in the URL, swaps in a different username, and boom, they can view someone else's private data. Why? Because the app doesn't validate ownership of the requested resource. Now let's have a look at a vertical broken access control example. An administrator logs into the app and sees the full user list in the admin dashboard. They can modify, delete, and manage everything, but here's the catch. An attacker tweaks a request, sets a parameter like admin and true, and just like that, they gain full access to the admin panel. All users, all data, full control. This is a textbook case of vertical broken access control, where a user escalates privileges simply by manipulating the request. Scary stuff, but very real. Now let's break down the common attack vectors behind broken access control. Here's what we're dealing with. IDOR, insecure direct object reference. When an attacker accesses other users' data by tampering with unique identifiers, like user IDs or object IDs, forced browsing. When an attacker guesses or brute forces hidden URLs to access unlinked but accessible resources. Privilege escalation. When a low-privileged or even unauthenticated user gains access to high-privilege features like admin functions. Missing access controls. When web apps or APIs lack proper restrictions, allowing unauthorized users to perform dangerous HTTP actions like delete, or put. Metadata manipulation. This includes things like replaying or altering access tokens, like JWTs, cookies, or hidden form fields to gain unauthorized access. Insecure CORS settings. Misconfigured cross-origin resource sharing can allow untrusted domains to access sensitive resources from your app. While this could also fall under Category 5, security misconfiguration, we include it here because insecure core settings often directly lead to broken access control. These are not theoretical. These are real-world threats that show up again and again in breached systems. Now let's move on to vulnerability examples and see how they actually get exploited. Here's a real HTTP request. A user sends a get basket 6 request with a valid bearer token and gets their own basket data back. That's expected, all good. Now let's try to break it. We change the ID in the URL to basket1, which doesn't belong to us with same authorization token. And boom, we still get a 200 OK response with full data. No validation, no restrictions. This is a textbook case of horizontal broken access control. All right, let's look at another example together. This time, vertical. An unauthorized user with no tokens and no cookies sends a simple post request to create a new user. They inject a parameter like role admin right into the body. And what happens? The server responds with 201 created. No checks, no AUth, nothing. Congratulations, the attacker is now an admin. This is a complete failure of access control and a perfect example of vertical broken access control. Now that we understand the risks, let's dive into some real code and see how these issues actually happen in practice. Let's walk through the code behind this vulnerability and how to fix it. On the left, we have the vulnerable version of the retrieve basket function. The app retrieves a basket based on the ID provided in the URL. No questions asked. There's no check to see if the user actually owns this basket. This means anyone can tamper with the ID in the request and view or even manipulate someone else's basket. That's a classic case of horizontal broken access control. Now look at the secure version on the right. The very first thing it does is extract the authenticated user from the request using security and authenticated users. Then, and this is key, it validates whether the basket ID in the request matches the basket ID assigned to that user. If not, it immediately returns a 403 forbidden with a clear message, access denied to this basket. Only if the IDs match does it proceed to fetch and process the basket. This small check completely shuts down the broken accessless control vector. It's a simple step, but it makes all the difference between secure and vulnerable code. Finally, let's talk about remediation. How do we actually defend against broken access control? Let's check our list and see what we can do to lock things down. Here's your go-to checklist. Always enforce access control on the server side. Never rely on the client side. Deny by default. Only grant permissions that are explicitly required. Follow the principle of least privilege. Users should only have the access they need, nothing more. Block direct access to sensitive files, endpoints, and internal directories. Use secure frameworks with built-in role and permission controls. Don't reinvent the wheel. Automate security checks. Run security code scanners, and don't skip regular penetration testing. With these controls in place, you'll be in a much stronger position to prevent abuse and keep your users' data safe. Enough theory. Time to get our hands dirty. Let's walk through the real attacks and then patch the code together. We'll show the full exploitation flow and then shut it down with proper remediation. Let's hack and secure.